right, so I guess we can start slowly but surely. So I will introduce you today, your hosts. So first, we have Emilie Guillard, which represents Eurofins Agroscience Services. She's responsible for marketing activities there. And we have also Alexandra, which is manager at Hiphen, specializing in imaging solutions. So without further ado, I lead to Emilie to start over with the introduction of today's talk about biostimulant product efficacy testing.
Thank you. Hello, everybody. So, a short introduction about the context for drone imagery in our experiment. So it all starts with a biostimulant manufacturer. We supplying the test item and the objective of the project. Together with Eurofins, we define the protocol in details. Then the team at Eurofins conduct a trial in the field, and the pilot flies the drone over the trials. And then Hiphen team analyze and deliver the data on their platform. Alexandra, can you explain this step?
Yes, sure. So hello everyone from me as well. I just would like to have the next slide. Yes, here it is. Sorry for that. So yes, at Hiphen, we work on image analysis. So that is to say all the images that you acquire with, for example, your drone, but also with other devices, we convert into valuable agronomic information. So to have this information, what we do is to assess, to use different models that can be photogrammetry, 3D models, but also different techniques based on deep learning to then describe, for example, the plant structure. So that can be the plant height or the biovolume. That can also be the leaf orientation, but also the lodging at the end of the crop cycle. But that is not all. We can, for example, as well assess biochemical information. So, for example, the chlorophyll content, or as well some plant stress or diseases. And in total, we have more than 70 agronomic traits that are available at Hiphen and that are listed and explained in our web platform that is called Cloverfield.
Thanks. So we will not, in this short webinar, we will not go through the 70 possibilities, but we will show some of the some interesting examples to give you an idea of what is possible. So to do so, we will focus on 3 case studies. So it's a real experiment that were conducted over the last 2 years across Europe. So the first use case will be a drought tolerance study in maize in Spain. The second will be in winter oilseed rape on nitrogen uptake. And the last use case will also be around nitrogen and yield loss mitigation in winter wheat. So the first use case, it was a screening experiment. So the question was really to identify the best candidate seed treatments across the different choices in order to select which one to test in a more detailed field trials up to harvest. This screening was focused on the first stages of maize, as shown below. It was a typical experiment with a randomized blocks. And we selected a suitable field in Spain, suitable for to get drought stress, and we manipulate the irrigation, and also we monitor the with tensiometer. We monitor the hygrometry in soil to really ensure that there was stressful condition. And as you can see, we first started with a severe stress just after crop emergence. And then we allow the crop recover with, let's say, a partial stress with some irrigation input, but not to optimum level for the crop to respond to this. Moving to next slide. So let's zoom on results obtained after the first flight actually. So we are capturing the response to the intense stress. You can see on the plot picture below that the leaves are curled, really showing that the crop was suffering. You are probably familiar with NDVI. It's one of the most known vegetation index that can be computed from drone imagery. In this experiment, there was not big variability of NDVI over the different treatments. It was not so helpful to select the best candidates. But if we look at the other traits that can be obtained from drone analysis, we identify two other traits that are more interesting if we compare, for instance, two plots nearby. Really, the chlorophyll content and the leaf area index were traits that helped us to separate better the most interesting candidates that we evaluated. I zoom a little bit on leaf area index. Maybe you are not so familiar with it. It's a way to estimate the area of leaf per area of ground. So you have a small picture here to help you understand. And you understand that clearly the higher leaf area index, the better the crop can use photosynthesis and grow compared to a lower leaf area index. So here in this use case, you already realize that drone imagery could really give us relevant parameters to analyze and to compare treatment or crop response to treatment. It was obtained on the whole plot. It was not just plant assessment or foliar assessment. It was a whole plot. Here, this experiment had 300 plots. So really, and it could be assessed in minutes, thanks to the drone. So it's really scalable, whatever the trial size. And we still get back to the picture, to the plot reality, even after the trial. So this is, in summary, what brings us this first use case. Alexandra now will show a bit more technically how we were able to select our best candidate for the next steps in this development project of the sponsor.
Yes, exactly. So, based on all the drone images that we got from Eurofins, we could analyze many different traits. And based on that, the different traits and also our analytics page on Cloverfield, we are able to filter in only some minutes the best candidates in your population. So we can filter, for example, only the best 10% based on NDVI, based on leaf area index, and maybe on chlorophyll content, but that really depends on what you would like to see in the end, on which parameters you think that your products will have an impact on. And based on all these traits, you can filter and you can select in some minutes the most interesting candidates for your question.
Thanks. So now let's move to the second case. Maybe we didn't mention there is a Q&A session available, and we will go to the question at the end of this webinar to make it as fluent as possible. So if you have questions, don't hesitate. So use case number 2, we move to the UK and to Poland. Here, the sponsor, they wanted to show if their product improved the plant nitrogen uptake. And they wanted to evaluate application at autumn and application at spring. So we have set up a factorial design with 2 levels of nitrogen fertilization to check differences in case of nitrogen deficit. And we planned the drone assessment at 4 critical crop stages, so based on the oilseed rape biology. 2 of these flights were placed shortly after the application of the biostimulant to help check and detect any differences. Alexandra, can you detail which traits were measured and based on the question that was requested?
Sure. So yes, here you are interested in the nitrogen uptake, and well, the nitrogen can be modeled as the leaf area index and the chlorophyll content. So both are parameters that we can measure very easily by drones throughout the whole crop cycle. And based on those 2 traits, but also on some other traits that are easily available, for example, height and biovolume, but also flowering, NDVI, and some other vegetation indices, you can, well, use the traits for your initial research question.
Thanks. Before to show these results, let's just have a comment on drone capabilities. So the experiment was in 23-24, and you may remember that the winter conditions were really difficult with a lot of rain and even snow. So it makes it really difficult to go and to enter into the plots for assessment. And actually, we were quite happy to get the drone because we could not enter physically in the plots to check the plants because of the condition, but the drone can always fly over the trial and get the data. Except, well, in Poland we had really early snow, so we had to cancel the first autumn flight in Poland because snow came really early last year. But yeah, if from above we can see the crop, we can assess, even if conditions are sometimes difficult to really enter into the field. So back to trial results. Let's go first to the UK trial. Here, this is the first flight data at autumn, and shortly after establishment of the crop. You see here that green cover, there are some differences, but they are quite light differences between, let's say, the lower and the highest value. It's more the natural heterogeneity of a field that was captured there. And we always need to remind that despite, there is data, let's keep caution when analyzing the results. For instance, here, so green cover show this picture on these, let's say, 2 plots, a bit extreme min-max green cover. And if we look at another trait for the same plots, here the chlorophyll content, actually the trend is opposite. Where there was the lowest green cover, there is actually the best chlorophyll content for the crop. So, and actually on a much wider range of value. So let's always be careful at what is the purpose of the study, what is, let's say, natural in a field, what can be the response to the product. We always need to be quite careful, exactly like with any other type of data taken manually as well. Moving to, again, as Alexandra showed before, the platform on the Hiphen help us to make this analysis because we have those visual way to represent the data over time between treatments to be able to really think about our data and our experiment. Now you can move to Poland, the Poland trial.
Yes, the second trial that was analyzed was, well, the spring assessment that you can see here in Poland. And, well, you can see, honestly, not a lot in the first image here. Well, there's not a lot of difference within the field, and you can see, well, the same trend. I just said that, well, for both the NDVI and the chlorophyll content, the range of results that you can see here and here are very small. And as you can see here in the same page, in the analytics page on Cloverfield that we've already showed several times for the different use cases, you can also see that, well, there's no trend between the normal and the low nitrogen. We should expect, or well, we would have expected a nitrogen deficit for the low nitrogen groups here, but well, as you can see, there's only the normal, the natural variability of the field that is present, but no real difference based on the different products. And for sure, well, I think that's not really what you would like to see, but at least all the drone image analysis and also the platform really helps you to digitize your field trials in near real time and to have the results very quickly. And that then can help you to, well, adjust the conditions to react very quickly. For example, also to stop if you see, well, there's really no effect, you can stop the trial and also save money in the end before the end of the campaign. And well, what is also very interesting here is that you can really go back to, not to the field, but to the images that were taken by the drone. You can compare the different treatments because you can visualize here the different plot clips. You can also see maybe if there are some outliers. And yes, all that in near real time, and so very fast and before the end of the campaign.
Exactly. We are all used to projects that don't necessarily run as expected. And this reactivity that offer the drone imagery, we don't need to wait for yield to estimate that, yeah, part of the trial is not as expected, and we can adjust the next steps in our experiment. So that's really, really helpful also for this reactivity offered. Let's move to next, last actually use case in France this time, and in winter wheat. In this experiment, the client expected that their biostimulant help to mitigate yield loss when there is a deficit of nitrogen. And they wanted to compare different products or different rates of same products. So again, there we set up a factorial design with a range of nitrogen deficits. And there was only one application timing and then 2 flights to check crop response. We looked at, we checked together with Alexandra, the team at Hiphen, which trait could be the most relevant to answer this objective. So Alexandra, if you can detail.
Yes, sure. So, well, here you were interested in the yield loss mitigation. So yield can be modeled as the biomass, but also the harvest index. And the drone can assess both parameters, well, indirectly with different rates. For example, for the biomass, that will be the green cover, the leaf area index, the biovolume, or the chlorophyll content. And for the harvest index, well, in wheat, that would be the organ count, but for other crops, maize, sunflower, that could also be the plant count. And for sure, well, the product efficacy will impact these traits value. And by comparing them, we can then assess the nitrogen product performance on, well, that what you would like to measure, the yield loss mitigation. So, well, as I just said, here in this case, linked to, well, the yield, we measured the biovolume, green cover, leaf area index, and the chlorophyll content with the drone. It is in theory also possible to assess the wheat head counting or the wheat head density buy a drone, but well, it is still very difficult between because the wheat heads are quite small, and well, you need a very high resolution of the drone to be sure that you count really the wheat heads and not something else. So in this case, well, we didn't count the wheat heads with a drone, but I will show you in a minute another system that can be very helpful and very precise in assessing the wheat head density. So to show you some results, for example, if you have a look on the chlorophyll content, so once again, the graph that you've already seen several times during this presentation, you can see that only the positive and the negative untreated check can be clearly distinguished, and maybe there's a very small trend between the severe nitrogen reduction group and the other group with only moderate nitrogen reduction, but there's clearly no difference between the different products in each fertilization group. When we have a look on another trait, the green cover, well, this trend can be confirmed, but we can also see that this product number 5 shows a very slight, but still difference between the treatments. And well, we can say, or at least estimate, that can be an indication that this product number 5 is less effective at mitigating the nitrogen deficit. That is really interesting because, on the field, I think that, well, the Eurofins couldn't see any differences. So with all the different, as we have so many different traits that are available by drones, well, the treatments just give more information, and that in the end, well, at least one of them can give you some hints, some small trends that you can use to make your decisions. And as promised, well, for the harvest index here in wheat, when we would like to analyze the wheat head density, well, as I said before, we need a very high resolution. And so that's why the literal system, so a handheld system that you can see here in the small image, has been developed recently by Hiphen and Eurofins in France. And it really helps now. Well, it will be available by the end of this year. And it really helps in small field trials to assess the wheat head density automatically and very robust because it's an automated model that is behind all that. You don't need to go into the field and count the wheat heads manually. So there are some huge advantages of this new method. And well, just as you're very close to the vegetation, this method is very robust. And if you want to know more about that, we're happy to say you something more about the system.
Thanks. So this was in very short an overview of some use cases to give you some input, some insights about what drone imagery can bring in case of biostimulant experiment. Before the question, a last summary about the steps to get to this stage. So the first step is to discuss the protocol together. Then we provide you access to the drone imagery analysis platform, Cloverfield. We run the experiment, of course. We acquire the data from the drone, and then Hiphen process the data and deliver on Cloverfield. And they are also offering to connect to your own internal database so that you get the data directly in your systems. I think now it's time for question and answers.
Thank you, Emilie and Alexandra, for the great presentation. So we'll move on towards the Q&A, and for that I will take the questions in order of appearance. Sorry. So The first question was from Franz Boudet, who asked for the availability of the presentation afterwards. So I just replied in the chat, but of course, all registrants will receive the webinar replay alongside the presentation in a PDF file format within their inbox as soon as tomorrow. So that's the first question. And then, so Jonathan asked if we can attain crop height or plot length without the use of LiDAR, accurate to 1 centimeter. So maybe it's a question for you, Alexandra.
That is a very good question. I think that many people are interested in that. So yes, you talked about the precision. I think that's the point here, because for sure it is possible to assess the plant height and also the biovolume, the plant biovolume of the plants, of the plots, with only an RGB camera. But you just said it, yes, the precision would be, I would say, more about 10 centimeter. So that's why for really small plants, we don't give the plant height, because yes, the precision is not high enough. And I think if you really would like to have a perfect precision, you just need to use the LiDAR. So if you have one, if you already have the LiDAR sensor, it is also possible on Hiphen side to analyze that and to give you then very precise height results.
Thank you, Alexandra. Then we got a question from Philip Cam, I guess, asking how many replicates. So I guess that was regarding the use case number 1. So Philip, I just encourage you to go check the presentation in a PDF file format tomorrow, just because in slide 7 here we have all the trial setup that are listed. And you can find all the information that you're looking for in here. Following question, which drone and which camera for this example? So I guess Alexandra or Emilie, you can both answer to that. I guess it was use case number 1, but in any case, the drone is mostly the same, right?
Actually, we have a fleet of drone across Europe that it varies across country. In Spain, actually, the first use case was analyzed. So the drone was a Matrice 1000 and a MicaSense camera on it. And for the other flights in France, UK, and Poland, we have a Mavic 3M. So again, it's a DJI. And actually now, as we are deploying and investing in more drones to cover more area, we are investing in this Mavic 3M because it's really a good quality for agricultural project. It's really fit for our needs.
I don't remember if you just said it or not, but yes, on that Mavic 3M drone, you have both an RGB and a multispectral sensor. So that is a real advantage. You have a lot of information in only one flight. So that's really great.
Yeah, absolutely. Next question from Pavel. Does an altitude or GSD matter when analyzing MS imagery, so multispectral imagery, like VIs, leaf area, angle, etc.? What GSD do you recommend? So maybe that's for you, Alexandra.
Yes. So I think here you were just speaking about the multispectral data. So for multispectral data, well, I don't remember the GSD by heart, but more, maybe the flight altitude. You can go with a Mavic 3M, for example, up to 30, 40 meters, maybe also a little bit higher, because, well, here we are really working with the pixel, and we don't need a lot of resolution. Where we are where we need a lot more resolution, and so a smaller GSD is for RGB flights, because here if you fly too high, well, we don't have enough information in the image. For example, we cannot see anymore if maybe, I don't know, this pixel is a stone or a flower or something else. But with a multispectral camera, that is less important, and you can fly, well, much higher.
Maybe to complete, Hiphen as an experience over years of analyzing a lot of different data sets. And so before each project starts together, we Hiphen provide, depending on the target, again, depending on the objective of the experiment, Hiphen provide the Eurofins pilot with a flight protocol, setting up the detail in detail about the camera settings, about the altitude, and so on, so that we fly at the right to deliver the right quality of data.
Yeah, absolutely, Emilie. Thanks. I was about to say exactly the same thing, actually. So we have a calculator at Hiphen to calculate and estimate the flight protocol. So we calculate GSD and all other parameters to ensure like a streamlined operations in the field for your flight operators. Thank you, Emilie. Next question is from Elizabeth Viegas. So how do you assess biovolume? I guess, Alexandra, that's for you too.
Yes, so biovolume, well, either from a LiDAR, but also from an RGB camera, we can visualize all the canopy because we have, well, the height of each data point, and with all the different data points, well, we have really the relief of the vegetation of the plot, and that's why, well, in a 3D space we can calculate the biovolume. And maybe to say a little bit more about the method behind, we compute, because we have, well, the same plot, for example, with the drone from different angles that we see, we can create a 3D dense cloud. And then, well, as we have the dense cloud, we have the different points of the vegetation, and we also have the ground. And then we can really make the difference between the height of each data point and the ground. And then this 3D space calculate not only the height, but also the volume.
Yeah, thank you. The next question is from Philippe Cam again, asking what are the weaknesses or limits of drone for such assessments? So I can't remember exactly the use case, but maybe in general, what are the limits of drones? Emilie, do you want to take over?
Yes, I think Alexandra mentioned one about the resolution. Even if we fly very low, 12 meters, I mean, the camera of the drone has a certain resolution, a certain number of pixels per square meter or per centimeters. And when she mentioned the use of the literal system to count with head, this is because of drone camera. Even if we fly low, I mean, the resolution won't be enough to assess very small item precisely. And I would say another weakness is we only assess what is visible from above. So for dense crops, we will never be able to assess what's going on between the soil and the top of the crop. The lower leaves, for instance, in cereal, we won't be able to assess them. Maybe Alexandra, you have other thoughts?
No, I think that's already, the most important limitations of the drone flights, because for sure it's very rapid. We can have a lot of traits, but yes, you're right, Emilie, it's only the traits that we can see from above the canopy. For sure, we cannot go into the canopy with the drones. Then, well, there exist other methods, but with the drone, well, today it's not possible.
Thank you. The next question is from Pavel again, asking how do we calculate green cover? Is it LAI or 3 dots? Maybe Alexandra can take this one.
Yes, no, green cover. I think, well, maybe in the future we won't calculate it anymore. It's more or less the same as NDVI, but calculated from the RGB camera. So that's to say, it's everything that is green in the image will be analyzed as green cover. So it is the green pixels divided by all the pixels in the image that will give a green cover in percentage.
Excellent. And how about chlorophyll content, which is a question from Gustavo?
Yes, so the chlorophyll content, well, it's sure everything is a little bit linked, but the chlorophyll content is calculated from the multispectral sensor, and here there are different estimations that we can make. I think some of them are just vegetation indices, and another one is based on a very complicated model where we calculate from the reflectance of the light that is captured by the multispectral sensor. We can calculate back the chlorophyll content, but also some other traits. Yes, so there are different methods. If you're more interested in that, don't hesitate to contact us after it, because we have, well, in the glossary on Cloverfield, we have explained in very shortly, in only some sentences, how the different traits are calculated and for which uses you can use them, for which use cases or questions.
Thank you. Next questions on the list. So the next one is from Didier Letiec, asking, well, there are a large number of disconnections, so maybe that's more a statement than a question. Didier, I invite you to check back on the presentation as soon as you receive it in your inbox, or clarify in the chat your questions, if you will. Thanks in advance. Then the next question is from Emmanuel von Kutzem. So saying that VIs can vary quite quickly from one moment of the day to the other over quite elevated ranges. Have you characterized this variability when taken from your drone? So that's first part of the question. Maybe you can stop here. Alexandra, can we characterize the variability of VI's assessment within a day?
I'm not sure if I really understood the question.
I think it's when we fly at different time, if we fly close to noon or if we fly later in the afternoon when the light is not the same, how this impact on the data?
I see. Thank you, Emilie. Yes, so sure. It is, difficult to have always the same results throughout the day, but that is why we provide an acquisition protocol to make sure that you fly well on the most appropriate time of the day. And another very important tool that we give you, that we give the drone pilot at Eurofins, is a calibration panel for the multispectral flights. And thanks to this calibration panel, it is less important at which time of the day you fly, if you have a lot of sun or not. We can eliminate some errors thanks to this calibration panel, but still, different parameters need to be respected. For example, if you have a lot of sun during that day, your calibration panel must be in the sun as well. You cannot put it in the shade. You need to respect the same conditions, if possible, all over the flight. But well, I know that is sometimes a little bit difficult to really make everything apply all the everything that we would like you do during the flight. But well, there exists every time a solution. For example, if really you have on that day a lot of clouds, but also some sunny parts, you can move, for example, your calibration panel during the flight, and then we can use it several times and make sure that your data, the final data, is the best possible.
Yeah, what I mean, the question describes something that really happened, and another thing is there is a quality check of the image once there is a drone flight, and when there are defects in the image or strange things, then it is detected, and in the worst case we can fly again, indeed, to reanalyze with a better data set. And what I mean, that's just to complete the other option. This is really something we all know that field work, you have to consider a lot of factors, and when assessing with a drone, you have also to consider the light situation, and not too intense light, which is difficult sometimes to get during summer in sunny area, and not too much changing weather. So in more, let's say, Atlantic areas, sometimes it's difficult because you have a lot of clouds coming. So light, no light, light, cloud. So yeah, we have to cope with this, and sometimes we can, sometimes we cannot. But we have also this quality check afterwards to ensure that we analyze something that is meaningful, and that we don't introduce another bias in the analysis. Indeed. At least if there is a defect in image, we know it, and we are not taking it as a normal difference from the crop.
Yeah, absolutely. Thank you, Emilie and Alexandra. So maybe to finish on this question, the second part was, when acquiring data, do you make multiple acquisition over a short period to get smooth or average data? So I can answer quite quickly to that one. So depending on what you want to assess, yes, we recommend flying at specific timings to get time series analysis. So, but it really depends on the use case, actually. Anyway, flying multiple times over the season is recommended, so we can really get insights from what's going on in the field. And did you collect all data at the same moment of the day? Well, again, so image analysis is environment sensitive, let's say. So we have, and people in the field have busy schedules too. So we encourage within our protocols to fly at specific timings and to maintain timings to make sure that the data will be qualitative and consistent. However, there's things that happen in the field and that needs maybe a bit more time to do, or a bit less time to do, or need to adjust the timing of the acquisition. So it's not a standard and robotic way of doing it. There's still a human behind that. So we are relying on them and impacted by other factors, in fact. But thank you for that great question, Emmanuel. The next one is from Isil. Can predictions be made for other elements such as P or K uptake? Emilie or Alexandra, which one is more confident replying?
I would ask Alexandra if, in terms of biochemical traits, we are able to. Or maybe this is. I'm not sure I understood really well. We are not. I don't think we are able to. To measure phosphorus or potassium in plants. But if the biostimulant product we are testing is looking at, let's say, phosphorus uptake or phosphorus used by the crop, and of course, if your product is effective and the crop responds differently to it, then if it will be shown in the crop physiology. It will develop differently from the neighboring plot, and this difference in crop will be detected by the drone. This is where drone is really interesting for biostimulant experiment, because all those models to all those traits analyzed from drone imagery, they look at the crop physiology, chlorophyll, architecture of the plant, and all these are crop response to your crop management. So I would say if your phosphorus or potassium biostimulant related product have an effect on crop physiology and crop growth and development, this should be detected.
Yes, that's right.
Thanks, Emilie. The next question is from Pierre. So he asks, how do you assess the harvest index if you cannot count the wheat heads? So actually, I think Pierre was very quick, asking the question before we cover the topic in the slides. But maybe Alexandra, you can add a few words on that.
Yes, indeed. For the yield, well, we need the biomass, but also the harvest index. And indeed, the harvest index for example, wheat, as I said during the presentation, is hard to acquire with at least a standard drone. But, well, thanks to the new literate system, we can now assess the wheat head density very easily and very in a robust manner. So, well, now we have all the parts of the equation to predict the yield as accurate as possible before the real harvest.
Thank you. Next question. How can we assess the efficiency of biostimulant on wheat to mitigate heat stress using drones in field conditions? And what are the traits we will get through drone? So basically, can we assess the efficacy of biostimulant product on wheat to mitigate heat stress? Emilie, have you ever faced any project like that at Eurofins?
Yes, so we have actually, because this question around abiotic stress and let's say resilience to climate changes is more and more relevant. We have actually set up a field platform in Spain in an area really prone to heat and drought. The difficulty of heat that it is often related to drought and to hydric status. So yeah, the idea is to have we can test in field, provided that the field conditions are creating this stress, and then on such field platform, we can analyze the response of the crop through drone assessment. Yeah.
Alexandra, do you want to add something?
Well, it's maybe the traits that you can then analyze. But, well, it really always depends on what you would like to measure. What is also possible, or what we often do with heat stress, is to calculate the temperature of the canopy. But for this, well, you need a thermal sensor. So that's always the same question. If you have one, we can analyze the temperature on top of all the other traits that are available.
Yes, this is typically where we have a drone, a DJI Matrix 1000 that allow to place different sensors depending on the case. And for instance, in Spain and in Hungary, we are equipped with a thermal sensor as well. So these are locations where we can actually check also the crop temperature at short term. And where we are not directly equipped ourselves with our drone fleet, we are also able to connect with external drone pilots who are often conducting drone survey for multiple industries. And we provide them with our, let's say, agricultural mindset to fly the right way for our experiment. And they fly with their equipment. So we were mentioning also LIDAR earlier in the question session. We are not equipped currently with LIDAR because, I mean, the needs for our field experiment is not high enough to invest into it. But we are able to collaborate with external pilots when there is a need.
Excellent, thank you. The next question is from Subarna Sharma. Do you have a list of some proxy that can help to understand root traits in wheat? So maybe Alexandra, you can take over this one. Actually, at Hiphen, we don't do so much root analysis. We are focused on observing what's observable actually. So visible characteristics of plants in field and indoor conditions both, but we don't do so much root work.
Yes, exactly. As Emilie mentioned before, with the drone and most of the devices that we use today, such as smartphones, satellites, or also the literal device, look on the top of the canopy and not on the roots. For sure, we could develop any device that can have a look on the roots to analyze them. Then what could also be possible for sure is that, well, today we don't have a list of proxies that show you the state of your roots, but maybe there is one, and that would be a very interesting project to link both to see if finally with a drone we can at least estimate the state of the roots. But that is a research project more than a standard traits that we have today.
Yeah, absolutely. Next question from Richard. So appreciate that you can share the data for these trials you're demonstrating, but did you see significant differences between treatments using this type of assessment? So I guess, Emilie, that's mostly for you.
Yes. Yeah, indeed. I mean, the purpose of this webinar was to give, general information. We could not get into indeed details about the treatments themselves and their efficacy. But shortly, so the situation was a bit different across the different use cases. In all seed rape, the results were not that clear, not so clear. Even trends were really not so clear to evaluate. In the winter wheat, the last use case, we could see trends, and we could see significant difference with untreated, not across treatments themselves, not across products, only trends, but with untreated, we could see significant differences. And the most interesting differences were observed in the drought use case, the maize one, where we were really in extreme conditions of stress, and we could really see significant difference across the treatment. In that experiment, we only had 3 replicates because it was a screening. Actually, we had limited quantities available, but there was a nice significant effects indeed. So it really depends, and of course, I mean, the drone analysis will not bring you differences that don't exist, and we all know that with biostimulant products, it's sometimes difficult to prove the value because the differences are light, and there is also a lot of crop variability in the field. But so I hope that I clarified a bit your question.
Thank you, Emilie. Next question. So we have something like 5 minutes remaining on the clock. So we have a lot of questions actually. So that's very good. Thank you for all of that. But we might run a bit out of time. So I'm trying to be quick. Next question from Pierre. Can your algorithm be adaptable to high resolution satellite data? So I guess that's mostly for you, Alexandra.
Yes, I don't know which traits you would like to analyze from high resolution satellite data, but yes, we are already working with satellite data with more and a little bit less resoluted data, mostly to get, for example, a leaf area index and NDVI. But yeah, we would be happy to see what you have in mind and what we can do.
Thank you. Hope this helps. Next question from Samira. Could your tools be applied to monitor crop susceptibility to abiotic stress or the effect of a fungicide application? We focus on foliar symptoms. So maybe I can answer this one. Let's say absolutely. With new tools like Literal, we have high resolution imagery that is accessible that can help sample multiple locations within your trials and even every plot to compute traits such as disease resilience, disease symptoms, infestations, and even at the leaf level. So that's that's really something achievable. And if you have any projects around that, feel free to hit us with a note for a specific follow-up discussion on that. Next question from Begonia. Can we skip from the analysis the border of the plots, and can we fix the size of the borders?
Yes, totally. Yeah, yes, totally. We define, so we acquire the whole plot, of course, but then we map the area that we want to analyze. And this is actually an information we provide to Hiphen from the field trialist, explaining, for instance, that the plots are 3 meters per 10 meters, but yeah, discard 50 centimeter or 1 meter of the borders, depending on the cases. So we can really adapt. And in case we see something then on the map or on the data that is, and we zoom in and we see sometimes a plot that is a bit inconsistent for whatever reason, for whatever border mistake, we can always repeat and analyze again to be a bit more accurate.
Yes.
Thank you. Next question from Sarah. Do you still use GCPs with the DJI Mavic 3M? So the answer is yes. Alexandra, do you want to say more?
Today, yes. I know many people are asking about that because, yeah, we made this year some experiments, and we saw that still with GCPs, especially for time series and for the height measurements, height and biovolume measurements, we still get better results with GCPs, especially in the, you have 3 axes, especially in the height axis. Today, we still recommend using GCPs, but we have some hope that during the next years, we don't need them anymore when the RTK on the drone will get better and better.
Yep. Question from Pietro. When you say possibility to cooperate with local freelance pilots, what type of agreement you have in mind? Emilie, do you want to share experience within your network?
Yes, that's probably more for me. Yeah, we cooperate on the need basis. If we discuss a field experiment with a customer where drone could add value, and we are not equipped locally with the right drone, or we are not equipped with drone in a few countries, then we contact local subcontractors, and we discuss and we establish a contract for that project. So depending then, of course, over years, the situation may repeat over time, and we can also discuss more longer term cooperation, but it always starts with let's say ad hoc contracts for the flight needed.
Thank you. Crystal clear. So we have maybe 2 minutes remaining, so we're trying to go fast for the last questions. Question from Abdallah. Why would we choose to fly a drone at noon, especially on a sunny day, given that high light intensity can potentially lead to misleading data that doesn't accurately reflect the plan's true status due to midday depressions? Well, absolutely, Abdallah, you're right. We wouldn't recommend to fly at noon. That this is something that is specified in our flight protocol that we send you and the drone pilots before each acquisition. So you're absolutely right. It's not recommended to fly at noon, and it's neither recommended to fly when it's too cloudy or at sunrise, sunset. Either way, it's not good options. But thanks for asking. Zineb, yes, you'll get the replay of the webinar in your inbox as soon as tomorrow. Then the penultimate question from Pavel, calculating vegetation indices, do you do calculation of canopy only or as per the whole plot? So maybe that's more a question about a process for Alexandra.
Yes, well, the difference between canopy or the whole plot, for me, the canopy covers the whole plot. But, well, for sure, especially in...
You mentioned in case the crop is not so dense.
Yes, so well, in this case, for sure, especially for the multispectral camera, we take all the plot. Also, if we see some soil in the plot, so that's why we try to crop, for example, the borders. But if one plant or some plants are missing, or as Emilie said, well, the plants are not so dense, the soil, yes, will be taken into account in at least the multispectral analysis. But well, in the end, that is also differences that you can see in the analytics tool, and that's also the idea behind to go back to the image. If you see, well, a result that is maybe a little bit strange for you, you can go back, you can see the plot and really understand why maybe this plot compared to another one, to a replication, is a little bit different.
Yep. And then last question, can you assess the temperature at the top of the canopy? Well, yes, using a thermal camera, you can absolutely. There's technology improvement too. So Mavic 3T, for instance, is a drone combining RGB and thermal camera. So you can acquire those two types of data within the same flight. So that's really also promising for the future. But yeah, absolutely. As soon as you can fly with a thermal camera, we can process canopy temperature and give you access to time series analysis within Cloverfield as per the other traits that we have in the glossary. And well, I think that's it. We've covered all the questions, so thank you for staying with us until the end. I think that's a wrap. I thank you, Emilie and Alexandra, for the great presentations and the answers. And well, until next time, thank you for everything, and speak soon.
Goodbye, everyone.
Goodbye, and thank you.